It's kind of crazy to think about, but what if I told you that half of the entire original internet was controlled by just 126 networks? No, seriously. That's the wild story of the Class A IP address, one of the first and biggest building blocks of our digital world. Let's break it down. I mean, just think about it today. Billions of phones, computers, smart TVs, everything needs a unique address. The challenge seems almost impossible. So how did the pioneers of the internet even begin to solve that puzzle back in the day? Well, in the very early days, the system they had was simple, but it was seriously flawed. Imagine having only 256 possible zip codes for the entire planet, but each zip code could have over 16 million houses in it. It was completely unbalanced. So this led to a pretty brilliant solution in the 80s called Classful addressing, which was just a way to create different-sized buckets for different-sized needs. And within this new system, Class A was basically the extra-large t-shirt. It was designed for the absolute giants. We're talking massive government agencies, huge universities, or the earliest tech corporations that were going to need a mind-boggling number of addresses. Now, to really get this, the best way to think about it is like a postal address. An IP address has two main parts. The first part, the network ID, that's like the zip code. It gets the mail, or, the data to the right city, the right network. The second part, the host ID, that's the specific street address that pinpoints the exact house or the exact computer you're looking for. Okay, so here's the technical breakdown. A Class A address is just a 32-bit number. The first 8 bits, what we call the first octet, that's the network ID. That's our zip code. The rest of it, the other 24 bits, that's the host ID, and that's the street address for every single device on that network. But wait, how does a router know in a split second that it's looking at a Class A address? The solution is so simple, it's beautiful. The very first bit of a Class A address is always a 0. Always. That one little digit acts like a giant signpost for all the networking gear, telling it exactly how to read the rest of the address. So efficient. So with that structure in place, you're probably asking yourself, just how many of these giant, extra-large networks could there possibly be? You'd probably think it's a huge number, right? But the answer is, honestly, kind of shocking. It's just 126. That's it. In the whole world, only 126 organizations could ever get a Class A network. This really tells you something. These were not for everybody. This was a very, very exclusive club. Okay, so only 126 networks. That seems small. But remember, those 24 bits we set aside for the hosts, for the individual devices, how many devices do you think each one of those networks can handle? Get ready for this. 16,777,214. A single network had more addresses than most countries had people back then. So you can see the thinking here, right? Let's make very few networks, but let's make each one an absolute monster. And right about now, I know what you're thinking. Wait a minute. The math doesn't quite add up, does it? If we have 7 available bits for the network part, shouldn't that be 128 networks? And why are we taking 2 addresses away from that giant number of hosts? Great questions. Let's clear it up. So the reason we only get 126 usable networks is because 2 of them are special. They're reserved. Network 0 is basically a placeholder, a null address that you can't actually use. And network 127 is super important. It's reserved for what's called loopback. Anytime your computer sends data to an address starting with 127, it's really just talking to itself. It's incredibly useful for testing. And it's the same idea inside every single one of those networks. 2 specific host addresses are off limits. The very first one, where all the host bits are zeros, that's the network's name. It identifies the whole network, so you can't give it to a single device. And the very last one, where all the host bits are ones, that's the network's megaphone. If you send a message there, it goes to every single device on the network all at once. So let's just quickly recap with this table. Look at that top row for networks. We have 7 bits to work with, which gives us 128 total possibilities. But like we just said, we take away 2 of those for special uses, leaving us with our magic number, 126 usable networks. Now look at the hosts row. Those 24 bits give us that massive 16.7 million number. But then we have to subtract 2, the network's name and its megaphone, to get our final count of usable addresses. Okay, so let's make this practical. Let's say you're looking at an IP address, something like 64.0.0.8. How in the world do you figure out its zip code? How do you isolate the network that it belongs to? Well, You use this really clever tool called a default mask. The easiest way to think about it is like a stencil. It's a special number that, when you lay it over an IP address, it perfectly blocks out the host part and shows you only the network part. And for Class A, that mask is always 255.0.0.0. The process itself is really simple. First, you take your device's IP address. Second, you line it up right underneath the Class A mask. Then, you do a little bit of binary magic called a bitwise AND. And what you get at the end, bam, the host part just vanishes, and you're left with a pure network ID, 64.0.0.0. It's this simple math that literally makes the entire internet routing system work. And here is where the scale of all this just becomes mind-blowing. Even though there are only 126 Class A networks, they are so unbelievably enormous that they control 2.1 billion addresses. Just look at this chart. That's 50%, half of the entire original IPv4 address space. Think about that. A tiny handful of giants held the keys to half the kingdom. So, if you're going to remember one thing from all this, it's this. Class A was the internet's first big idea for organizing itself. It was a foundational system for creating a small number of absolutely massive networks, built for the biggest players on the planet. And that leaves us with one final huge question. This system was designed for a handful of giants. But what happens when the internet explodes in popularity, and suddenly billions of regular people and small businesses all need an address? This system, for all its early genius, simply wasn't built for that reality, and its limitations would force the internet to evolve all over again.